Hi, welcome to MRU E-Learning powered by Malla Reddy University. Myself, Dr. Battaputula Venkatratnam. So, I'm working as Assistant Professor in the School of Engineering Data Science Department at Malla Reddy University, Secunderabad. Today, I want to discuss about the basics of deep learning. So, in this deep learning today, what is our agenda? First one is the introduction. Next one is the difference between deep learning and the machine learning. Why we need the deep learning? Next, what are the advantages of deep learning? So, biological inspiration of human brain. Next one is the artificial neural model. Next one, structure of artificial neural network. Next one is the activation functions in deep learning, loss functions in deep learning, and types of deep learning networks in real time, and applications of deep learning techniques and limitations of deep learning. So first we will start with the introduction of deep learning. So what is the deep learning? Deep learning is a subset of machine learning. So it is inspired by the human brain, artificial neural network. So it will extract the object features automatically by itself from the large amount of data, that is known as the deep learning. So deep learning is a subset of machine learning. So it is inspired by the human brain, artificial neural networks, and it will extract the features of one particular object automatically from the large amount of data by using the neural networks. That's why it is called the deep learning networks. So for examples, deep learning recognize our face. Example is the mobile unlock. Next, voice assistance. Next one is the medical image diagnosis and self-driving cars. Chatbots like ChatGPT, Google search like this. We can implement the using deep learning. So next one is the differences between the machine learning and deep learning. So this is the diagrammatical representation between differences between the deep learning and the machine learning. So machine learning is a subset of the artificial intelligence, and again deep learning is the subset of the machine learning. So feature extraction, if there is any object means for example face. What are the features of face? Features: ears, nose, mouth, teeth, eyes, like these features are there. So to extract those features, machine learning need the in machine learning we have to extract those features manually. But in deep learning, it will extract those features automatically. So next one is the data requirement. So in machine learning, we require the only small amount of data to the middle amount, but in deep learning we need the large amount of data to train the model. So next one is the complexity. So complexity is the very low in machine learning, but in complexity is the very high in deep learning techniques. So hardware requirements, CPU is enough for the machine learning models, but deep learning models we need the GPU and the TPU. GPU stands for graphic processor unit, and TPU stands for the tensor processor unit. These are the basic differences between the machine learning and the deep learning. Why we need the deep learning? To avoid the disadvantages or limitations of the machine learning, we are moving to the deep learning. So what are the limitations or disadvantages of the machine learning? We will discuss now. So first one is the data dependency. See, what is the data dependency here? Say the performance of machine learning model is heavily depends on the quality and quantity of training data. Poor quality or biased data can be lead to the inaccurate predictions or unfair outcomes. Unfair means as reason. If you want to train the machine learning models, we have to give the exact input. If there is any biased data or any missing data, we are unable to predict the exact output, and that's why it is called the data dependency. So total outcome depends on the exact correct input data. So next one is the high computational cost. So small business persons cannot bear this cost of the machine learning. So next one is the complexity and interoperability. So if you learn the one machine learning model, so if it is any bias is there, any mistake is there, any unstructured data like this unbiased data is there, then if prediction is not correct, then it is unable to take the decision making. So next one is the risks of bias. There is a bias, means bias so leading to unfair and unethical outcomes, especially in sensitive applications like hiring or lending. Next one is the job displacement. Say here, while machine learning creates new opportunity, reskilling the workforce retains the significance of challenges. So it is needed to the manually feature extraction. And next one is the poor performance on unstructured data. Machine learning cannot handle the unstructured data. So this is in limited scalability we have in the machine learning. To avoid these disadvantages, we are moving to the deep learning. So these are the advantages of deep learning. Whatever disadvantages are there, we are overcoming those disadvantages in deep learning. Those will become as a advantages of the deep learning. First one is the works well with the images, audio, video, and text. Using deep learning, we can work with very well with the images, audios, and videos, and text also. So in deep learning, we will get the high accuracy and end-to-end learning also, means encryption and decryption also will do that very securely. Next one is the automatic feature learning. So if there is any object, so in deep learning, that object features automatically extracted by the deep learning models. Next one is the handling large and complex data. So if you want to train the deep learning models or algorithms, so we need the large amount of data and complex data. So if there is a less amount of data, it is not possible to train the deep learning model. So improved performance compared to the machine learning. In deep learning, we improve the performance of the model, means accuracy of the model and prediction of the accuracy model. Next one is the handling non-linear relationships. In deep learning, we can handle the non-linear relationships very easily. Next one is the handling structured and unstructured data. In machine learning, we can handle the only structured data, but in deep learning, we can handle the structured data and the unstructured data also. Next one is the predictive model. If you train the model, you can predict the objects easily. Based upon the prediction, the organization will make the decisions very easily. Next one is the handling missing data. Suppose there is a face that is called an object. If they are missing anything on the face, automatically it will fill that object missing data and train the model and gives the accuracy or exact prediction of the output. Next one is the handling the sequential data. What is meant by the sequential data? Here, using RNN, recurrent neural network, and the short-term memory networks, we can handle the sequential data. Sequential means continuous data. Continuous means such as the time series and the temperature and air and speech, text, etc. There, those are handled by the deep learning. Next one is the scalability. What is meant by the scalability? So according to increasing volume of data, they can be efficiently deployed on cloud platforms and edge devices. So according to the, if there is a large amount of data, it is not possible to store in the PC or laptop. So we can store the in cloud platforms also using the deep learning models. So biological inspiration in human brain. What is the relation between the human brain and the deep learning? So deep learning developed based on the human brain. So human brain contains billions of neurons connected through the synapses. Like that, in deep learning also neural networks connected to each other. So In learning, in brain, learning happens by the strengthening of or weakening these connections. So whatever we have neuron connections in brain, based upon the connections, either strengthening or weakening of those connections, our brain will learning happens. In our brain, learning happens. Like that, in deep learning also, deep learning models are inspired by this idea. So artificial neural mimic biological neurons in a simplified mathematical way. So what is artificial neuron model? What is artificial neuron model? So this was inspired by our brain. So like in brain neurons, how they learn, how they remember, like that in deep learning also, these neurons are connected to each other and they will learn and they will remember the objectives. So artificial neuron receives the multiple inputs. What is meant by the multiple inputs means, so it can receive the images, multiple images, not only face image, cat image, dog image, apple image, like this, multiple inputs at a time. Each input is multiplied by a weight. So what is meant by the weight here? Weight means it connects, it flows the data between the, it controls the data and the flow of the data in between the neural networks. Neural networks, a bias is added to the weighted sum. So this is the another step. Next one is the result is passed to the output function and activation function produce the output. So we will discuss what is activation function, what is bias, what is loss. So these are in the next slide. So this is the artificial neural model. So what is the first one? It will receives the multiple inputs and it will add multiplied by the weights, and it added to bias is added to the weighted sum, and next one it will process that one to the activation function and to produce the output. So now we will discuss about the structure of artificial neural network, ANN. ANN stands for the structure of artificial neural network. So it has the main three parts. So input layer, hidden layer, and the output layer. So what is the functionality of the input layer? Input layer receives the input or raw data. So hidden layers are processing that input data, and the output layers will produce the final prediction or final output of the input. So these are the three parts of the structure of a neural network: input layer, hidden layer, and the output layer. Input layer receives the input or raw data. So whatever input layer receives the data, that the data transferred to the hidden layer. In hidden layers, that data will processed by the hidden layers, and that processed data are the output to send to the output layers. So what makes a network deep? So what is the deep neural network? A network is called deep when it has a multiple hidden layers. So why we need the multiple hidden layers means, suppose if you want to train the one deep learning model or algorithm, we need the multiple hidden layers. When you have multiple hidden layers in your deep learning model, then that model will train perfectly. It will learn the input from input data very perfectly. So that's why we need the multiple hidden layers in the deep neural networks for image processing, and early layers learning edges, while deeper layers are learn objects. These are the examples. These are the examples of the deep neural networks. Next one is the activation functions. So what is the purpose of the activation function? So the activation function decides either neuron is active or not. So already we discussed neural networks. Neural networks means we are passing the data using neurons throughout the network. That is called a neuron network. So either that particular neuron is active or deactive. So the activation function decides. So again we have some common functions are used in real time. So those we will discuss. First one is the sigmoid function. So this is the one activation function. So these function values are 0 and 1. So for binary prediction, we can use the classification or prediction, we can use the segment. Binary means if there is a output is exact matching to the actual output, then it is the 1, otherwise it is 0. So next one is the tan h of function, activation function. So these values are in between -1 and the 1. It is somewhat better than the segment function. So next one is the ReLU. So this is the most commonly used activation function in nowadays and present days also. So this is very powerful and useful activation function nowadays. So this because it is a simple and efficient. Next one is the softmax. So if you want to classify the multiple class predictions, what is meant by the multiple class predictions means when it is softmax is a one activation function. So when we use this one means multiple classifications or multiple predictions. Suppose if you want to classify the number of fruits. Number of fruits means apple one class and mangoes one class, RNNs, and like this different types of multiple fruits are there. If we want to classify those multiple things, then we can use the softmax activation function. So this is also called the output function also. So now how we can train a deep learning model? First, we have to train the process of teaching the model using data. So whatever you have the data, suppose take the image processing. Suppose if you want to process the human beings' faces, then you can take the number of human being images as input. So you can teach your model using those images. So human being face is like this. So human being face contains the so and so nose and ears, teeth, mouth, heads, like this. You have to teach the model, and your model will learn according to your input. So training while training your model, it involves the forward propagation and loss calculations and background propagation. We will discuss what is forward propagation and what is loss calculation and what is back propagation. So this process is repeated for multiple iterations called the hypothesis. Whatever we are giving the input data, that input data has to we are teaching the model, that model learning our data. So it will give the prediction between the output and actual output. So how we are predict the actual output means we are giving the one dog image. Prediction means the model has to identify that image is exact, that is dog only. So that is the prediction. Actual output means dog. So in this between training involves the forward propagation, loss calculation and the back propagation. So this process is we are repeating multiple times, that is called the epoch. Next one is the loss function. What is the purpose of the loss function? Why we need the loss function? So using this function we can measure the how wrong the prediction is. So how much prediction is we are losing while getting the output. So that's that purpose. So if loss is heavy, our model performance is not good. If loss is low, our model performance is good. So better. So types of deep learning networks. So there are so many types of their deep learning neural networks, but here we are discussing the only main two things. These are the main types. So CNN and RNN. Using CNN we can handle the image related objects. Using RNN we can handle the sequential data objects. So we will discuss about the convolutional neural networks, the CNN. So using CNN stands for the convolutional neural network. Using CNN we can mainly use it for the image processing and video processing. Using this convolution network layers, we can extract the features of one video or one image. Again, convolutional neural network contains the input layers, hidden layers and output layers. and sigmoid and activation functions, last functions like this. Using input layers, it will take the input as image and it will extract the features and prepares the one graph, weight graph, and it will passes to those weight graph into the hidden layers, and those hidden layers and again process those data, and it passes to the output layers. So and in CNN also used for the medical imaging in medical field also. So next one is the recurrent neural network. So this neural network is used to the in series of data. So what is the series of data? Already we discussed previously. So series of data means language translation, time series analysis, and speak recognition, and wind flowing, temperature. Like this we can handle using the RNNs. So apart from RNNs, we have the LSTM and GRU also. These are the advanced versions to solve the memory problems. So what are the applications of deep learning? Where we can use the deep learning in real time means in education system we can use the deep learning in finance sector and the transportation in health sector. These are the majorly used. So many sectors we can use the deep learning techniques. These are the major things. What are those things? In healthcare, finance, education, and transportation sector. So using this we can take the we can make the decisions based upon the deep learning prediction. So we have some limitations of deep learning. So what are the deep learning requires a large amount of data. If you want to model your deep learning algorithm or deep learning model, so we need the large amount of data. At least we need the 1,000 above images and 20,000, 30,000, 40,000, like this we need the large amount of data. So using small amount of data we cannot handle the deep learning models. So high computing power. So models are often difficult to interpret. So deep learning models are very difficult to sometimes interpret. So overfitting can occur in the model is too complex. If model is too complex and data is high, there is a chance to overfitting error occur. So ethical issues like bias and privacy must be considered in the deep learning. So these are the limitations of the deep learning. Okay, thank you.